Example 1 here on straight lines is taking a look at converting between forms of straight line equations. So here we're asked to find the equation of the straight line that passes through 1, 1 and 3, 0, and we want to write this in the form ax plus by plus c equals 0. And just note here that a, b and c all belong to the integers. Okay, so these are all integer values here. Okay, so how would we tackle this example here? Well, the first thing we can do here is use the idea that y minus y1 is equal to m times x minus x1 here. Okay, we can use this formula here. Simply all we need is the gradient m, and we need to take one of these points. And it wouldn't matter which of these 2 points we use here, as the straight line passes through both of these points. So first let's work out the gradient m. And to work out m, what we simply do then is y2 minus y1 divided by x2 minus x1. And here, it doesn't matter which of the two you would label, say, y2, and then label that one y1. It wouldn't matter in this case, but I'm simply going to label this one as y2, and that would be y1. And then in that case, if this is y2, it must be x2 here, and x1 there. And now, all we need to do here is just substitute the coordinates in. So y2 is 0 minus y1, which is 1. We divide this by x2 minus x1, so that's 3 minus 1. And that gives us minus a half there for that gradient. So m is equal to minus a half. So all we need to simply do now is substitute our gradient into this formula here alongside one of these two coordinates. Here I'm going to simply substitute in 3, 0, but again it wouldn't matter if you was to substitute 1, 1 in. So here in that case we're going to get y minus 0, so that would just give us a y here. And this is going to be equal to m, which is minus a half, times by x minus x1. And our x1 here is the first x coordinate, which is just simply 3. So minus 3 here. And here all I'm going to do now is expand this right hand side. So therefore, y is equal to minus a half x plus here, because that's minus a half times minus 3, giving us plus 3 over 2. And then in this case here, we want everything, or when we say everything here, we mean the coefficients. We want a, b and c here to be integer values. So in that case here, if we multiply through it by 2, we're going to eliminate these coefficients of minus a half and this 3 over 2 here. Okay. So therefore, if we times through by 2, we obtain 2y is equal to minus x plus 3. Now here we want it in the form ax plus by plus c equals 0, so we need to get everything onto one side here. So in that case, if we add x to both sides, and we subtract 3 off both sides, then this right hand side here will be equal to 0. So to finish that here now, we're going to get x plus 2y minus 3 is equal to 0. And notice this is now in the form that we require here. This is ax, where a is 1, plus by here, where b is 2, and our plus c here, where this c is minus 3 there. Okay, so x plus 2y minus 3 equals 0 gives us the solution to example 1 there. Example 2 here on straight lines is taking a look at parallel and perpendicular lines. So the line L1 has a gradient of 2. So this example here is split into 2 parts. Part 1, we're given a second line L2, which is a parallel line that passes through 1, 1. So how would we find an equation for this line? Well, the first thing to note here is that this line is parallel. And remember, if two lines are parallel, they share the same gradient. So in that case, L2 has a gradient of 2. Okay, so we can note that down. So L2 also has a gradient of 2. And in that case then we can simply use, again, y minus y1 is equal to m times x minus x1 here. All we need to use is this coordinate here, this 1, 1, and we need to use our gradient of 2 here. So therefore we obtain y minus 1 is equal to 2 lots of x minus 1. So in that case here, if we expand the right hand side first, we get 2x minus 2. And now we want it in the form y equals mx plus c here. So in that case, if I just add 1 to both sides, we get y equals 2x minus 1 there. Okay, so that gives us the solution to the first part here of example 2. So if we note that here, this is the first part. Let's take a look now at the second part. So this is for the line L3, and this is a perpendicular line which passes through to 3. So if L3 is perpendicular to L1, then what we know here, so L3 is perpendicular to L1, then in this case here, the gradient for L3, so we call it M here, is going to be given by minus 1 divided by the gradient of L1. So gradient of L1. Okay, well in that case here, the gradient of L1 is 2, the gradient for L3 is minus 1 divided by 2 there. So we obtain minus a half here. So all we simply need to do here, again, is use this formula of y minus y1 is equal to m times x minus x1 here, and simply use the gradient here that we've obtained of minus a half, and this coordinate here of 2, 3. So that's going to be y minus 3 is equal to minus a half times x minus 2 here. Okay. Well here again, if we just expand the right hand side first, what we get here is y minus 3 is equal to minus half x, so minus a half x, and then minus a half times minus 2 will simply give us plus 1 there. Okay. And here now, again, if we just rearrange this so it's in the form y equals mx plus c, we just need to add 3 to both sides. So therefore, y is given as minus a half x, and then add 3 to this one here to get plus 4 there. Okay, so the line L3 has equation y equals minus a half x plus 4. Okay, so this is for L3, and this line here, this equation, was for L2 there. Okay, so that gives us the solution to example 2 there.